Over the next months, Clough will be bringing you expert series podcasts from some of the exciting technology projects we're engaging in and some of the new engineering that we're bringing to the world. Hello, my name is Jillian Formentin, and I am absolutely thrilled to be bringing you our first podcast expert series. I am a business development manager with Clough, but I am actually an engineer. So I'm a chartered mechanical engineer, I'm very proudly so, and I have a commitment that some of the extraordinary projects that we are bringing to industry are also talked about in a way that's a bit more understanding for people. And this is our first of many sessions, and it is my absolute privilege today to introduce to you Hamed Sharafizad, who is Clough's Chief Electrical Engineer. So in a moment, I'm going to ask Hamed to tell us a little bit about himself and what has him be here at Clough and his particular area of interest. But I want to let you know that he's a highly proficient and knowledgeable engineer, and he's got extensive experience in project life cycles from design and concept phase through to front-end engineering design. We are very lucky to have him. I've had the privilege of working closely with Hamed on a project already, and I've only been with Clough for a few weeks. So this is an opportunity to, bring some information and some of the human side of our engineering and engineers to the public. So, Hamed, maybe we start by, thank you for being here, but what has you be at Clough? Maybe just a little bit of your history to give us a bit of an idea about, the man behind the Chief Electrical Engineer.
How far do you want to go back? That's the key question.
As far as you're willing.
Without compromising. Yes. Look, I've been a Perth boy. Most of my living years have been here in Perth. I did my high school, primary school, high school, and tertiary education here in Perth. I finished at Curtin University and went down the path of engineering. Now, interestingly enough, I actually wanted to do podiatry. And that never eventuated because the way it was structured at the time, it felt a little bit too risky. So I thought I'll do 1 year of science or 1 year of engineering, which had similar units at the time. And I thought, you know what, if I absolutely botch the first year, I can stick with engineering, and that can't be too bad, surely. Luckily, I did the first year of engineering, and I thoroughly enjoyed it. Back then, the university courses were slightly different to what they are today. It was a lot more involved back then, with many more units. I stuck with engineering, and I remember landing my first job, summer internship with Alcoa, and really didn't look back. Every year I was chasing summer works with different companies, and it was quite interesting. And it took me from the office to the mines, working underground, and then back in the office, and then overseas over the years. I've worked in Australia, I've worked in Israel, I've worked in the US, traveled to India, worked in PNG and other places. So thanks to engineering, I've had a bit of a global footprint traveling and following the projects as they go. Through the process, I also met and married my missus, who I met in Israel. Through that union, we're proud parents to 3 beautiful kids.
Oh, fantastic.
When I came back from Israel, I was craving to get back into the energy sector, which is where I was initially before I left to go overseas. And Clough gave me that chance. It was in 2001, and I remember joining the first project on Lakshmi, which was a gas processing facility in India, and haven't looked back since. Went from one project to the next, effectively working on Napa refinery, which was in PNG, and then worked on the Mari wellhead platform. And at this point is when I finished the project, I was approached about the chief's role. This was in 2007. I felt I was in over my head by taking on the role. I didn't think I was ready for it with only 11 years under my belt. And I thought to myself, well, give it a crack. What's the worst that can happen? I took it. And again, it was a challenge. It was a bit of a growing pains, but it was a challenge, and managed to overcome those challenges. And through the years, I've been able to work with a wonderful bunch of engineers. I've learned from them. I'm hoping they've learned from me over the years, and also being able to work with the likes of yourself on BD work, concept work, and also be able to work with other disciplines and functions.
Oh, brilliant. Well, thank you. It's really great, because I'm just reflecting on it. Clough's over 100 years old and continues to be a very dynamic and ever-changing company. We move with regards to what the projects that are needed are and the area of interest, and you will have moved and fluctuated with and probably driven some of that change over the years you've been here. So it's really good. And one of the things, what kind of brought us together today is this conversation that we want to have about battery energy storage systems. So maybe we start with, well, what are they? Often shortened to BESS. I hear them talked about as a BESS. And how is that different to traditional solutions that you might have used before?
Yes. Get used to acronyms. We live in a world of acronyms these days. BESS is it, but you're absolutely right. BESS are energy storage technology systems that absorb and release, electrical energy on demand by using specially developed batteries and inverter technologies. What makes them unique is the battery technology, and these days, lithium-ion batteries are the most commonly used batteries. Being energy dense allows them to have a smaller footprint, which makes them more viable, especially in facilities where available space is a constraint.
So just say, how big are they? This is not something I can put in my pocket. But how big is a typical BESS system?
Yeah. Look, it depends on it depends on how it's going to be used. And the operating as part of the power generation and operational scenario that is expected. Typically, they're containerized units, and they're coupled with other generating systems. For example, gas-driven power generators, or hybrid solutions through having solar farms or grid systems.
Okay, good. So, I'm used to maybe on a smaller scale, like you think about it like a UPS, like on an uninterruptible supply for a computer system or something. Is it kind of like that, but for very big applications?
In a way, yes. It's a common question that's been asked. How's BESS different to a UPS? I guess a BESS system and a UPS system have similarities in that they store energy and expend it when needed. In a nutshell, that's how they operate. BESS units are designed for rapid charge and discharge cycles, and the inverter is able to perform bidirectional operations. I think that's the uniqueness of the BESS technology. And as you mentioned, it is for larger industrial deployment.
So how is a BESS different from a UPS system?
UPS technology basically doesn't deploy inverters that allows for bidirectional use, and typically uses lead-acid battery technology, which is not as energy dense as the lithium-ion batteries used with BESS technology. The lead-acid batteries for UPSs are perfectly suited for standby power, where there is long periods between outages.
Right, okay. So I'm imagining that you would use them, for instance, on a power station situation. You might have a gas-fired power station, or hopefully in the future hydrogen. And then you'd have a BESS would be in case you ran out of fuel, for instance, or if there was some problem with the station. Would that be an application for it?
Well, the industry applications are far and varied. For facilities within various market sectors that we're involved in, the reliability and availability of the facility is key. I mean, the clients do stipulate that into their scopes of work that we get. And depending on the facility's operational criticality and or its remoteness, various systems and aspects, including reliability, need to be considered during the design phase. This is done to ensure a facility's continuous functioning and readiness. And that's key. So power is not immune from this. Power is one system that has to allow for reliability and availability. When power has to be generated on a remote site, design electrical engineers not only have to determine the required system parameters, but also power generation sources and configurations that allow for this reliability and availability. It becomes a bit of a challenge because then you have to understand how we do projects and where we do projects. Clough projects are usually remote and islanded. They need to be self-sufficient. In terms of generating and distributing their own power needs, that is a key. BESS units allow for scalable energy storage systems that can be used as part of this power solution.
It's really great, Hamed. Would you share a little bit about some of the challenges that this equipment helps overcome?
Sure. Operational history of power generation on various sites tells us unscheduled shutdowns of running power generators do occur from time to time. It just happens. Now, there are many causes for this. The ones that come to mind is, well, how well equipment are maintained. There could be an operator error. It could be unscheduled faults or activities. There could be a disturbance on the system, a large load coming online that wasn't expected. There are many reasons for this. An unscheduled shutdown of a running generator basically puts pressure on the remaining generators. This occurs when once you have one generator out of action, the remaining generators have to be able to pick up the load that's remaining, and causes the voltage and frequency to move outside required tolerances. And once that happens, the generation falls over.
Right, and so you're really protecting your more expensive hardware, aren't you? As well as
that's right. I mean, at the end of the day, it just puts stress on the system, and that's something that we need to protect against. But to overcome this problem, conventional gas or diesel power generation designs allow for generated spinning reserve. What does spinning reserve mean? It's the extra generation capacity that is introduced by running one more generator than the expected required power generation. You would have come across terminology such as N+1, where N stands for the required generation, and the +1 is the additional capacity of a running generator to allow for this eventuality. It doesn't have to be N+1, it can be N+2 or more, depending on the, operating scenario that we're operating under.
So someone choosing a solution that uses this technology could save themselves a lot of capital.
Absolutely. Look, it's not efficient, let's face it. By running additional generators, we use more gas, more fuel. We have more emissions through CO2 emissions. We will have more maintenance costs. We will have, the need for installing additional generation itself is a problem because you will have to allow for more materials, for more equipment. For that to be installed, there are CapEx costs and there's OpEx costs. All of that plays a part. But until now, and I'm talking about in the last few years, battery technology hasn't been viable from a technology point of view and a cost point of view. That has changed now. BESS units as energy storage can form a virtual spinning reserve in a hot standby arrangement to achieve the same effect as you would with traditional design of running additional generation. And of course, BESS units do have other, uses as well, other than the one that we've just been talking about. It can be used for what we refer to as peak shaving, where it can compensate peak loads, peak load periods, especially on power facilities, it can be used for black start on a facility where we would traditionally use diesel engine generators. This can replace that, or at least reduce the capacity of a diesel that's required. It can be used in conjunction with renewables, where the environmentals can be unpredictable, and it provides for that power compensation, power smoothing to allow for other traditional power generators to come online.
Very good. I mean, it sounds like a no-brainer, doesn't it? Like if like right now, if I was going to install power, generation, and I would just be installing some of these along with it. But I understand you've had some barriers to bringing this solution to the client. Could you help tell me a little bit about some of those barriers and how you and your team have been bridging those?
Back in 2019, on another gas project, at this point, the design had shifted quite a bit, and the process loads had gone up. And as a result, power generation needs had to move to be able to cater to these additional loads. What it meant was we needed more generation. And we had to be able to provide that stability and availability through additional generation. And it was becoming bigger than Ben-Hur. What we decided to do was to work with the vendors and the technology providers to see what other solutions out there. We were quite aware of battery technology, but we were also aware that they were quite expensive. And they didn't quite cater to the footprints that we were hoping to. But through much discussion and, of course, with technology improving, we realized that there is a viable solution. And I remember we took the battery energy solution to the client at the first meeting. It was early 2019. And we explained to them that we wanted to have generation. And instead of the N+1 spinning reserve, we wanted to have that virtual spinning reserve through a battery technology. There was silence. And the electrical engineer said no. That was the first response I got from him. And the reason for it was that he wasn't convinced that it was going to be cheaper, and he envisaged that it was going to be a large installation. Again, through much work with the OEMs to provide that information and to do simulations, we proved to them that it was a viable solution instead of having more generators. It took a bit of back and forth, but eventually it was adopted. And the project has, placed the orders on the power generation, and there is a battery energy storage system amongst it.
Oh, congratulations. I think every technological advance, it takes the early adopters, the ones that kind of take that risk. I imagine that electrical engineer would have been, on the hook for making sure that worked. And kudos for him for, allowing a new opportunity to actually get installed.
There is a bit of about a decade or so ago, we faced a similar challenge. I remember where they wanted to bring a fuel tanker and dock next to what is an iron ore port. Now, the idea of bringing hydrocarbons that are highly explosive into an area where nothing is protected against hydrocarbon spillage was just a no-no. And the Port Authority pretty much balked at the idea and said, you're going to have to do all these changes. Part of the changes included lighting. And LED technology at the time was an up-and-coming technology, and some of the suppliers were trying to put their brand out there and their product out there to get the project references. It got to the point where one of the suppliers came to us and said, we'll give you the light fittings for free to install.
The LEDs?
LED lights for free to install on the port so that we can get the project reference and we will prove that our product is superior to the current technology, which was your high-intensity discharge lamps at the time, your high-pressure sodiums or mercury lamps.
It's only 10 years ago.
It was,
That's amazing.
Just 2010, and I took it with a full-blown proposal to be able to implement this. And And the response I got was a no. We want to stick with what we know. Now, look, fast forward a decade, they don't even...
You'd be laughed out of town if you didn't suggest LEDs now.
Yeah, absolutely. I mean, there's no way we could go down the path of the traditional, lamp design.
So what are you most proud of? And when you look out at the future, what do you hope for or what do you see for this technology, Hamed?
BESS units are scalable. They are building blocks to scale up or down, depending on the project's needs, of course, to generate, use, and store energy. And the technology improving can only lead to more flexibility for engineers to use from concept to reality. Improved availability of BESS also means using it with renewable energies without compromising on reliability. And it's gaining much needed momentum in our industry. Going forward, every engineer's goal should be looking at ways to reduce greenhouse gas emissions. Now and in the future, the use of BESS is one small step in that direction. For Clough, the commercial and environmental benefits of BESS units are key drivers in its decision to embrace their use on future projects.
Very good. Well, thank you so much. I certainly know more about this technology than I did a few minutes ago. I really appreciate you bringing this in a way that is so easily to understand. Thank you. So that was Hamed Sharafizad. It was just a really great conversation and bringing some real light to things that are really sometimes quite confusing. So stay tuned for other expert series conversations that we'll be bringing to you over the next months.